Hi guys, in this first class I will start with some review from the sequences before I continue with the other materials. Then we will start learning series. If you remember, right, the first problem in the sequence, and actually the main problem, right, was to, right, seek for the convergence of any given series, and then we just express this either using one of these notation, right? You can express the convergence of any sequences using one of these. So basically I'm going to use some limit techniques to find the convergence of any given sequences. For this purpose, if you remember, right, we learned the main limit theorem. The first thing, right, we learned about the convergence of the sequences was the main limit theorem. Main limit theorem was about the main algebraic operation between the sequences. Let's say I have, right, the two sequences. I know where they approach, look at that. AN approach, right, M, L, and then BN approach M. If you want to know, right, where they would go when you add them, obviously you expect, right, to see they would go L plus M. And then you can do the same thing, right, for the subtraction operation. And also, I can do the same thing, right, for the multiplication. And then I can do the same thing for, look at that, the division operation. As long as M is not 0, otherwise, right, that wouldn't be defined. And also, look at that, the fourth rule was about the constant multiple of any sequence. So you can just multiply the result of the limit by the constant number later. Okay, these four rules, right, will help us to solve some of the problems. But later we will see that main problem is not going to be okay to be able to solve all the sequence problems. Let me remind you, okay, how we were using main limit theorem for some sequence problems. You will remember, right, that these type of examples from our classes, especially when I had the polynomial on the numerator and denominator. So, if I am asked such a question, right, I can use the main limit theorem, but first of all, I should remember one of the main sequence limit, right? We prove that. So I know the 1 of n limit is going to be equal to 0. So my main problem is, well, we'll turn into this one. How can I use, right, the 1 over n limit, which I know what it is, right, to be able to solve the problem given to me? Later we will learn, okay, better technique, and then you know that part. You were right asking to me about the L'Hopital's. But if I want to use, right, this one combining with main limit theorem, I should do this one. First of all, look at that. I'm gonna take the common term out. You see, I have these, the common terms around, so that I can cancel them out, and then I can use, right, the limit 1 over n sequences. What I mean by the common terms, look at that, right? Yes, as you see, right, there is no common terms here, but I noticed that the n, I have the n common term on numerator and the denominator. So I can use the common term approach to take the highest degree terms out, so that I can cancel some of the terms, and then also I can use, right, this limit. If you look at, right, the bottom part, let me show it to you by using the different color. Look at it, guys. If I knew, right, the 1 over n limit is equal 0, I can use, right, this combining by the main limit theorem to see, if you remember from our class, to see this will go 0. This part will go 0, right? Great. And look at that. This is 0, and I will have left, right, after seeing that one 0, n times 2, or look at that, I have now n squared times 3. Since still I have, right, this term here, look at that, 3 is there. It is just 0. Okay, then look at that, I can cancel some terms. Did you see that? Now, n will cancel, and I will just have the limit n goes infinite, and then I will have 2 or 3 to the n. So it is similar to, right, this one. And then I had, right, the fourth rule in my main limit theorem. I can take the 2 over 3 out. So limit when n goes infinite, 1 over n, as you see, it is going to be 0. Did you see that? So that's how I use, right, the main limit theorem, combining with, right, this one of, right, the benchmark examples. Another example we can solve, right, before starting something new. Okay. Limit when n goes infinite, 2 to the n plus 1 over 3 to the n plus 5. To be able to solve this problem, as in the previous example, look at that, I'm going to use another feature we saw before. Look at that. If you remember that one, limit n goes infinite, x to the n will be 0 when, if you have, right, a number less than 1. You see, when I have, right, a number, which is x here, if that number is less than 1, absolutely, then this limit will go 0. How can I apply, right, this rule, this feature, to be able to solve this problem? I will use a similar technique as I did in my previous problem. I will take the some terms out, so that I can use this feature, guys. 3 to the n, 1 over 5 or 2 to the 3 to the n, sorry. Okay? You see, guys, I have a term here, look at that, x is equal here to 1 over 2, and then another x I have here 1 over 3. So I can use my feature to get their limits. So their limits are going to be 0, right? Great. These are going to be 0. I know that. If they're 0, now I can write what I have left in this way. Limit when n goes 0, n goes infinite, sorry, 2 to the n times 1, I don't need to write it down, and also look at that, I have the 3 to the n. N is common term, right? So I can combine those in this way, and then another x here, which is also less than 1, that's why it is going to be 0. But look at that, right? We solved this problem by just using, right, the one rule and then combining by main limit theorem. But of course, you need to use your algebra, okay, to do all these operations. Okay, this is just a review for the main limit theorem. Now, in the next section, I'm going to start a new feature to be able to solve, right, some other limit problem.